Honestly, okay, Cole, all I really have to do is give you the Pythagorean theorem and you got everything. Okay, guys, DJ, put that away, get your workout. Trying to find all my geometry stuff. Okay, guys. Shh. I'm not really supposed to be talking. Why not? Fine, because of my voice. It won't come back. I could lose it for 3 months. I've lost it once for 5 years. Uh-huh. That's asthma.
What?
I sounded like this for 5 years. Yeah, it was awful.
What?
Yeah, you're going to have to pick out what we did. Because it's asthma. Okay. Zach, don't throw. No. Okay. Shh. Okay, guys. Guys. Shh. Pythagorean theorem says if a triangle is a right triangle, and you should know this because you've known this for years, because you've done Pythagorean theorem, what, since grade 6? The big thing here that you have to realize is what the sides are. The legs are always joined by the little square. So this is A, and this is B, and this is C. So it says the square of the legs equals the square of the hypotenuse. Always write an equation to set it up. Okay, so it's A squared plus B squared equals C squared. Okay, Zach? Zach, what did I just say about not talk? I'm not supposed to be talking. So you're wasting my voice when I do that. Okay, okay guys, if I have a triangle and I know the three sides, A, B, and C, and if I get A squared plus B squared equals to C squared, then I know it's a right triangle. It's the converse.
Oh, wait.
Well, that's the first 2 lessons. We had 4. 4, 5, 6. I guess we had 3. Then we had distance formula. And all distance formula is Pythagorean theorem. Okay? This is Pythagorean theorem. The distance, girls, the distance between x2 and just pay attention now, I won't talk very long, and x1 is the length of that side. The length of the other side is the change in the y's. How do you know how far you've gone? You subtract them. Now, it doesn't matter the order when you subtract them, because guess what you're going to do? You're going to square them. So Pythagorean theorem says d squared is equal to x2 minus x1 plus y2 minus y1 squared. And if you solve for d, you square root it. I notice that some people are struggling with how to undo squaring. You square root to undo squaring. Yes, we did this on Friday.
Oh, Friday?
Friday. And I made up a problem. And let's see. The distance. Pay attention. D is this length right here in a right triangle. It's the distance between any 2 points. Zach, do you need to sit someplace else?
No.
Then you need to be quiet. Murray. This is the square of the distance. This is the distance. So how do you solve for D? You square root and you square root. Okay. Now, you can use the formula if you want. I think it's too hard. Well, actually, let's make this. No, I want to make this. Hang on. I want to make this so it works. I just happen to be lucky. Okay. How do you find? Now, I can plug this into the formula, but the problem is, when you do it wrong. That's the problem. So if you do -1 minus 2 and you write that, okay, guys, that's just wrong. So I don't like you to do that. It's so much easier if you just say, I really just want to know, and I could draw a picture, how far apart the x's are. So the distance is the square root of, now be careful, think of temperatures. It's 1 below and it gets to be 2 above. That's a change of 3 degrees, right?
Yeah.
Okay, Sydney, is that right? What's the other distance? -3 to -7. How far apart are those? 4. That's the easy way to do it. If you use the formula, that's the hard way. Okay, do you recognize that?
Yeah.
Do you recognize that? Look at that. Shh. It's 3, 4. What's the other side? 5. Now, you can use a calculator. So if you want to use Pythagorean's theorem and square it out, you may. But I don't need to. Yes?
So we have the triples up there.
No, you need to know. So thank you for reminding me about the triples.
God, I reminded you.
Yeah, well, I would have gotten them. Okay, you guys? How do you generate the triples? If you can remember how to generate them, then you don't have to memorize them. You square this, and you round it down by 1. So 3 squared is 9, so you get 8. You divide that in half. 4, and then take the next consecutive integer. 4 plus 5 adds up to the square of 3. Okay, Zach? How do you do this? 5 squared is 25. So half of 25, if you round it down, is... Okay, but you round it down, and then these two add up to the square of that. So if you can remember how to generate them, you can remember them. 7 squared is 49. Yep. So half of 49 is 24 and 25. It's not so hard, is it? How about 9? Square 9. 81. Half of 81 is 40. These add up to 9 squared. It's kind of nice. Once you know the pattern, it's a lot easier. Can you do 11? What's 11 squared?
121.
Good. What's half of 121? 60 and 61. The odds work this way all the time. I could do another one. That's really all you need to know. Now, you can take multiples of these as well. Like if 3, 4, 5 works, then 6, 8, 10 works. You could multiply by 3, 9, 12, 15. But you always can use Pythagorean's theorem. Okay, TJ? Because you're always allowed a calculator. Not a problem. Now, there's one other kind, and those are the evens, and the only one you need to know is the 8, 15, and 17. Yeah, that's because of the chord. So it's 8, 15, and 17. You don't have to use them, but they sure make life a lot easier. Okay, one last topic. Ready? One last topic, and it's the equation of a circle. And I figured out a way to help you get these to work. Equation of a circle. You have to know that. Okay? Cole, you going to move?
No.
Okay. Here's my circle. We'll take the point that's equidistant from all those edges there are HK from the circle itself. Now it's alphabetical. We did this Friday. I'm reviewing it. And here's a point on the circle, x, y. What is this distance called? That's the radius. This is just Pythagorean's theorem again. It is. But I got to figure out what a is. So it's this number minus this one. So this is x minus h. And the other one is the change in the y's, which is y minus k. And what you do is you square them. It's just Pythagorean's theorem. So it's x minus h squared plus y minus k squared equals that distance you told me was r squared. That's the equation of a circle. Yeah. I'm sorry, what? Yeah, we'll put some numbers in there. Okay, so what's number 5? Sorry. Is this the circle stuff? I want to stay with the circles. No, I'll do that later. But let's do the circle stuff. So if I have -2, 3, and r is equal to 5, I want the equation of the circle. Okay, you either remember the formula, or you say, well, you know, I'm going to take a point on the circle, Cole. We're going to call it x, y. How do I find, it's just distance formula. How do I find the distance between those two? You subtract them. X minus -2 squared plus, and then I subtract those. Now, could you do 3 minus y? Yes, but I prefer y minus 3. Squared equals r squared, which is 5 squared. That's it. So you don't have to memorize the formula. You can just put a point on the circle and just do the problem. What if I have this? X plus 3 squared. Yep. That's it. What about that one? Back? What's the center of that circle? Now what I'm going to do is write the formula down underneath it. It's x, because I figured out a trick for this. It's x minus h squared plus y minus k squared equals r squared. Well, r is easy. What should be easy? What's r? R equals 8. K is easy. Yeah. That's what it says. R squared equals 64. No, this is the equation of a circle. Like we have equations of lines and equations of parabolas. What's K? K equals 5 because those match. But you know what? These don't match. I have to make them match. So I figured out this trick in my last class. Minus h has to equals positive 3. Well, what does h have to be then to make that true? -3. If that helps you. The other way I do it is what will make this 0, what will make that 0.
How did we get 64?
I made it up.
Oh.
I just made up a problem.
Oh, you just wrote that.
Yeah. And those are the two things you have to do with circles. Pardon? They might, or we could do the problem off the blue packet that has a, and I didn't do an example like that, that there's one you have to do a little more work with. So I could bring that up. Let's finish with the circles so I'm consistent, if that's okay. I'll bring it up. It'll take a second. Maybe I can answer your question individually.
Regular window at?
Not sure I understand what window you're talking about.
Like your window is the X and X.
I always zoom decimal, but that's just me.
It's like one.
Why are you graphing something?
No, it's just all changed up on mine.
I can fix it.
Yeah, like how it is.
Now I do have all the answers up for the homework packet, but not for this one. What do you ask?
Window, what is it?
No, just go zoom 4. There. Okay. I gotta go find this. Is it that? Right here. This problem. This is the last problem on the blue packet. Do you have your blue packet out? Last problem. It says, and if you don't know what to do, draw a picture. Draw a picture. Center of a circle's 3, -1. Oh, I don't want that. Wrong one. Okay. I did that hard way. Okay. This is at 3, -1. About there. And one point on the circle is 6, 2. I got to move this. So 6, 3, -1, and 6, 2. This is the center. This is the point on the circle. That's the radius. Okay, TJ? Not a very good circle, but that's okay. Find the equation of the circle. And then this is 3, -1. Well, that's why you got to pay attention. I just want to find the distance between x, y, and 3, -1. How do you find the distance between the x's? TJ, how do you find that? How far apart are they? Well, if I had 5 and then 3, how far apart would those be? Well, what'd you do with these two numbers? You subtract them. So what are you going to do with these two numbers? Subtract. So it's x minus 3. I'm sorry? X just stands for a number. Just leave it. How far apart are these? Cole? How far apart are these? It's y minus, careful, a -1 squared. And then what else do I need? I need the radius. You know what? I know this point on the circle. It's 6, 2. So how far apart are those? If I have 6, 2, what's the radius of the circle? And 3, -1. This is the distance formula. Okay, TJ? So the distance is equal to, or should we do r squared? Let's do r squared, it's easier. R squared, it's just Pythagorean's theorem. How far apart are those guys?
3.
3. Okay, TJ? How far apart are those guys? That's it. R squared equals 9 plus 9, which is 18. And that's what goes in right there. No, radius is the square root of 18.
That was actually lots.
Yeah. No, because of what units we're in. If we're in micrometers, no, it's not very big. Okay. It's just, you know what? The whole thing is the same thing. It's just Pythagorean's theorem.
Is that literally the only form we need to know this whole test?
If you just apply Pythagorean's theorem, but if you don't do the work, you won't feel comfortable applying it. It's this length squared, that length squared, so that's x minus 3, that's y plus 1.
You help me on number 7.
Oh,
Center
is this the blue packet still?
Yeah.
Okay.
Center equals 0, 0.
Oh,
And the radius is 4. Yeah.
and a point on the circle is x, y.
Yep.
So what's the distance between those two?
So x minus 0 squared
Plus.
plus y minus 0 squared, and that equals 16. So
Yeah, 4 squared. So x squared plus y squared equals 16. Okay?
that's the answer?
Yeah. Yeah, don't make this hard. Answers are posted. So you can check. Yeah, which one do you want to do?
Okay.
Is this number 5?
Yeah.
Okay. What kind of triangle is it? Okay.
Triangle ABC with radius A equals
Oh.
C equals 812 and C equals 24, 0.
So you have to find the lengths of all the sides. If we get that, then I don't have to draw the picture. If you draw the picture, you got A, B, C. So you want to find these lengths. So I want to find A to B. So I want the length of that. It's the square root of, well, how far apart are 2 and 8? Sydney?
Yeah.
6. Zach? How far apart are these? 8. Do you recognize that as a Pythagorean triple?
Yes.
What is AB equal to?
10.
10. Good.
Oh.
Yeah, don't use distance formulas. It's way too hard. I know, because you were taught that, and I can't. You can go to the bathroom. Okay. How about BC? Okay, Cole, how about BC? That one's probably not going to be as nice. 8 to 24.
That's
16.
and that's 12.
And that's 12. Now, since there's a common factor there, I'm kind of curious to see if it's a triple. So I have a triangle here where this is 16 and this is 12. What goes into both of those?
2, 4.
2. No, 4. So that's 3. Ooh,
That's 4.
that's 4.
5.
5.
But, you know, that was the original triangle. This one's 4 times bigger. So how big is this then?
25. Or, no, 20.
20. It's the only thing I have to be careful of.
That's so cool.
Because these triples are always the same. Lane, put your phone away. These triples, they're always the same. That's fixed. They're always there, and any multiple is always there. And they're the only ones that are integers. Okay, Zach?
Hey,
We're just doing questions here. What's the last one I got to do? I got to do A to, oh, I need a different color. I need to do AC, don't I? So AC equals, okay, 2 to 24, it's 22. 4 to, is that 0? That's 4. And I don't think that's a triangle. I mean, it's a triangle, I'm sorry. I don't think that's a triple. Because if I divide by 2, I get 11. Cool. And I divide by 2, I get 2. Are 2 and 11 in my list?
no.
No. So I have to do it. This is 442, I believe. Am I correct?
22.3.
Plus 16, which is the square root of 8, 458, which is approximately what?
That is approximately 2.36.
Okay, so what do you have to do with all these sides? You have to add them up. And where's the other one?
Yeah.
So it's 10 plus 20 plus 22.36. Whatever that is. 0.36. Is this a scaling triangle? Isosceles or equilateral? It's, are any two sides the same? No, so it's scaling. Those are the types of things. If you do the practice test and you get them all right, you're fine. I haven't given it to you yet. But I will right now.